I am going to design and 3D print every single tool that I need to service a KYB fork, and then we're going to see if they actually work. On the agenda for today, we have the fork seal driver, and I'm really confident in that one. It doesn't take a lot of force to drive in those fork seals. We'll be building one that can do the dust seal right here and also the fork seal up inside of there. It's going to be a two-piece wraparound design, and then I'm going to come up with a fancy way to hook them together so that they don't fall off. If you've seen the Motion Pro Ringer, they have like two separate rings that interlock, and as you can see here, I already redesigned that one and printed my own. That's how it works. You have these rings that wrap around the outside, and then once you stick these together, you just rotate that and it can't come off. So I designed this just for fun to see how it would work. This is kind of my test before making a YouTube video about how to do it so that I for sure know what I'm doing. But I decided that the ringer type design isn't good enough for me because it was someone else's idea. And it is very cool, it works super well. But yeah, they have it patented. So I'm gonna let that thing be theirs. It's cool if you wanna make one for yourself, but I'm gonna leave it at that. So I design injection molded parts all day for a living, so what I'm going to do is a oversized snap feature type stuff like you might see on an injection molded part. Basically, it'll have a catch on the one side and snap together on the other side. That should work really well, and since it's all 3D printed, that kind of leads us to be able to do a little bit more complicated of a part there because it doesn't have to be machined. So with that out of the way, let's get into what I need to actually get the dimensions right, because this was not really the right dimensions. I kind of just guesstimated on a lot of things to just throw one out, and it doesn't really work. So for reference, I have the new fork seals right here. This is the fork seal and the dust seal. I'm going to open these up, and this is going to be the main thing that we're basing our measurements off of, because this is the part that we're actually driving. We know the diameter of this tube. That's the other important part. I already measured that in the last one, got it dialed in, so don't need to change that. And normally I would just go back and edit the part studio that I already created for that, which is right here. It's one common part across both sides. That's why these, that's why these little posts here are offset. They're protruding on this side and cut out on the other side. That is just so that it's a common part. And then same with these, they're common parts too. I don't really think it makes sense to do that the same way on this snap feature design, because I could just do one big solid one that clips onto the other one. But at the same time, I'll have half of the parts. So give and take, I still have the same amount of unique parts to print, but I just have to print one of each of them instead of two. So for the sake of how I want to outline this video and actually show you how to do this, I'm going to start a new part studio right here, and I'll bring up the screen so that you can follow along, and I'll try to explain what I'm doing, at least for the first part of this, and then when it gets into the snap feature, I think I'll kind of just blow through it and maybe try to voice over explain a little bit, because there's a whole lot of information once you get into that little bit more detailed stuff. But to get the initial shape, I think you'll be surprised how easy it really is. So let's jump into it. Okay, let's get started here. I'm gonna start by making a sketch on the front plane. I just hit N to go flat to that plane and P to remove the planes. L is for a line, and I'll start above the origin and go down right underneath it. And then I'll hit Shift M, which gives me the midpoint constraint, and I will make it so then these are mirrored across that origin. Now I'll set that to what, like 2.5, I think. And that is my revolve point there. So now I'll make my first line For the part, I'll use a horizontal command from here to there and here to there. That's just the H key. I use keyboard shortcuts for everything at this point. I don't think I could make myself do it without it. I mean, I do this 40 hours a week using keyboard shortcuts for everything. So I'm sorry, but I don't think I could do it without using keyboard shortcuts. Oh, that was D for dimension. So this is a 48 millimeter tube, measures 47.91 millimeters. I think I'll still do 48.5. Seems, oh, I forgot to do millimeters. 48.5 millimeters. So, yeah, you have to type in millimeters when you're set to inches, and it's not worth switching all my stuff over to millimeters just for this, especially because I'll be using inches for everything else. So other things that I want here, I need to have a bump out on the bottom, and this is going to give me a little perch. If I open up the dust seal here, let me make my little screen down on the bottom here bigger. You can see the dust seal has this edge is what sticks out, and we want to miss that and push on this edge to drive that in. So I need to have this slot clear that. I'm not going to put a dimension in for right now. I'm just going to say roughly where I want it to be. And then I'm going to go up here and maybe do like a nice little chamfer kind of deal. Just make sure that we're not grabbing any constraints there. And then I'll go right up into place there. Now, where do I want to drive on this? So now when I work on the actual fork seal driver, I want it to push on the outer edge. That is going to be the safest spot to push. So what I'm going to do is just have that, you can see it cuts in. And then I'm going to, I don't know why I'm so high up actually. This should be way down here. I don't know what I'm thinking. Drag this down, do another horizontal command on that. Ugh, getting ugly. So when you move stuff around this much, that's when it's actually nice to dimension things as you go. But it's all right. Look at that. See, we can just get around it. We're fine. So next thing to measure, I'm going to take our dust seal and I'm going to measure the total OD, outside diameter, if you're a layman. Looks like we would have a good amount of clearance with 2.1 inches. Maybe we'll go 2.12. That gives us plenty of room. So now we'll take this, and the easiest way to do this is just go 2.12 times 0.5, and that gives you, who knows why, I don't, I forgot to do that on this one. So that should be 48.5 millimeters times 0.5. So let's get that adjusted a little better. Now we will see what is our outside diameter of the fork seal. Looks like we are 2.29. So this one, we don't want more clearance than we have to have, because that's just less driving surface. So yeah, we're like 2.299, I think, is a good spot. So for good clearance, I would say like 2.85 would be as much as I would go that way. So 2.85 times 0.5 gives us that right there. And then as far as our total outside, that's one that we can make up ourselves. So I'll just go off of the thickness here. I think 0.75 thick is fine. We're not injection molding it. Wall thicknesses doesn't matter. So you can see the blue is what we haven't defined yet. So the depth of this is the next thing that we're going to define right now. Let's put it at 0.17. 0.17. And then how much room do we need to actually drive that in? That is a good question right there. I think what we'll have to do for that is pull the dust seal out. I'll get a screwdriver and pop that out real quick. Got that out now. Just worked around it. Now I can slide that up. There's that little guy too. And that fork seal, it's not very far in there. So there we go. You can see there's a little clip that's in there too, a little metal clip. That's what's sticking out. And then right on the other side of that is our fork seal. So I'm going to take the depth measuring end of my calipers, stick it down in there. That is sitting on the fork seal. And it looks like we only need 0.26, like just over a quarter of an inch. Or 260 thou if you're a machinist. So just for good measure, I think at least 3/8. And then let's just set this at 45 degrees or 135 working from the other direction. I think that needs more. Let's go 150. That looks a little cleaner. So now is that magical part I was talking about, where we can just take this. This is the revolve command. I selected the face I want to revolve, the axis that I want to revolve around, and then I say one direction, 180 degrees, and we have the shape that we want. So if you were just creating your own fork seal driver and you aren't quite as committed to 3D modeling as I am, you could be done here. This is half of your part. You just print that twice, stick the two together, and drive that in. Anything on top of that you do is just gonna make it better. The next most important thing I would say is to add some sort of aligning feature. So like pins on this side that key into the opposite side and don't let it go up and down from each other. And then next most important from that would be an actual locking feature, which isn't that important. Like if you go on the Rocky Mountain website and order a Tusk one, they don't have that. Like the actual $35, $40 one that you buy, that's like the cheaper option. If you want to buy the $80 Motion Pro Ringer one, then it has a locking function. But typical one that you buy doesn't have a locking function anyways. So it's not a big deal if you can't 3D model one. But the Ringer design was actually super easy to model. If I just walk through my design tree real quick here, you can see what that sketch looked like. I just had this same thing here. I added this deal to cut out so that I'm only pushing on the outside of the fork seal, but that was before I actually had the fork seal in hand, and that is the first surface to stick out, so there's no reason to do that, I don't think. So I just revolved that. I'll just walk through it. Revolve that, and I'm left with this like immediately, which is 90% of the way there. I threw that radius on. Most important part right here, added the logo on the back. You know, don't forget that. Next sketch here was for my post holes, the aligning features, whatever you want to call them. Extruded those. This side out, that side in, so we have a common part. And then I did a move face so that I have clearance. I gave it, well, I think 5 thou. Yeah, 0.005. That just makes it so that those parts can easily connect to each other. The reason there's so much draft or angle on them is just for printing, because this can be hanging out and the printer will just print that no problem. If I show this one, Those printed like gorgeously. That was on the Prusa. It's a MK3, not one of the new ones or anything. I got it like 5 or 6 years ago. I want to get one of those new bamboo ones, but I haven't. They haven't worked, so I'll probably 3D print some of the stuff on that and see how it turns out. If it's really nice, then I might be making that too. I'm also working on a headlight bezel for the Beta. We'll be showing that here soon too. Doing some fun little side projects here for the Beta while I wait on the parts for the electric bike. I'm going to be doing a trip with the boys here in a couple weeks down to Green River, Utah. I don't know if you've ever been there, but it's really cool. It's pretty much down by Moab. Same kind of riding. Super fun stuff. It's about the best riding you can do anywhere. So very excited for that. Just want to get this bike tip top. We're doing fork seals, oil service, new tire on the back, new headlight. Obviously, I'm putting in this headlight. This is a rigid one that I had laying around. That should work great. But yeah, I'm going to go ahead and model the rest of it here and just do like a time lapse of that, because that stuff's a lot harder to explain. I'm sorry. I'm no good teacher. But real quick to go over our dimensions. So our outside dimension here is 2.85. So let's measure that. Is that right? Did I say that right? It shouldn't be 2.85. I read it wrong. That should be 2.185. See, this is why we check stuff. Man, I've been making a lot of mistakes here. It's almost like everything's harder when you're trying to video yourself doing it. Anyways, look, let's, yeah, you even missed a button. Okay. Wow, that changed the look of everything. So let's change some of these arbitrary dimensions to something we like a little better. I don't think that needs to be 150 anymore. We can do 145. Yeah, that's fine. Okay, so that's what this guy looks like now. It might be a little bit stubby. Maybe we'll give it a little bit extra length. And that's all easy to change. Like we could just go in here, and the way I have it set up, if I just say 3, then it is proportionally bigger. It's important to always set up your models that way, because I mean, if you're interested in doing like product design or anything like that, you are working for a client, which means that they change their mind constantly, and you have to go change the model constantly to make it the same. Okay, it's actually a couple days later now. A key thing that I did was I took that ringer type design that I made, and I actually used it to install fork seals on my one fork and my buddy's forks, and learned a couple key details about it that were pretty crappy. Number one was those sharp edges that I left on there to print nice and flat against the print bed. Cut the crap out of my hands. That sucked. You're not really pushing on it a whole lot of times, but enough that if you leave a sharp corner, it's going to hurt you. So first thing I did was make this rounded shape to fix that. And then also the distance of the part that protrudes to pound in the fork seal needed to be longer than I thought, because you have to use that to drive in the bushing that's in there too. I didn't realize that, so updated that to be a little bit longer, and then came in here. And then other than that, I am just adding in my snap feature design, the stuff that I already talked about doing. You can see the hinge is what I started with, and then now I'm designing this snap feature that is designed to work around the rotation of that hinge. Pretty slick that way. Just got to make sure it's nice and clearance and everything. So when I say that I design snap features for injection molded parts all the time, I don't do it like this, really. I'm not using like injection molding thicknesses and deflection, stuff like that. I kind of just rolled with whatever on this, because it's not that important, I feel. So it's a lot bigger and thicker than you would see on like most injection molded parts,
pretty much any snap feature I've designed for an injection molded part is a lot smaller than that. But that's all right. It makes it a nice big positive snap with a good handhold on it. Obviously, like I said before, the most important part is the logo, so we got to throw that on here. I'm adding little grip sections next to it also. Going to throw that on that face, nice and pretty like such, and then rotate that around and do it on the other side too. I did put this as for the hinge. I made a 3D printed pin. It's also designed to work with a 1/4-inch bolt, but I'd have to lower that thickness a little bit to make it actually work good on the part that it actually pounds into. So there's clearance on the first two, and then you kind of have to pound it into the last one. We'll see how good that actually works. Getting the slice ready here, and let's print this thing. So throwing up in Prusa Slicer here, I added a lot more supports than I usually do. I have been having a little bit of issues with layer adhesion, and so I wanted to make sure that it worked really well. I put a new build plate on, and I think that helped a whole bunch too, because this turned out really nice. But because of all those supports, I had a whole lot of cleanup to do. I definitely would do less than this in an ideal situation. Sorry for my voice, by the way. I'm very sick for filming this part of the video. I guess just for the voiceover part of this video. But I got it cleaned up here, went to pound that pin in. That last little bit where I made it a little tighter, ended up breaking that little knob off. I knew I would. I should have just started with a punch of some sort to begin with. I'm using my dumb office tools because I'm not willing to go out to the garage to get my nice tools. But that pin still works even without the nice top on it. And hinge is really nice. It's nice and smooth, so it's not going to cut up my hands trying to slam that thing down into the groove. Turned out really nice, and I know you want to hear how that snap feature works. You're just waiting to hear how good that thing is. Yeah, it turned out perfect. It turned out so nice. You have to check out this next part here to see how it actually works when we do the fork seals. So I mentioned I also was making all of the tools for me to do a fork service, and I did. I have kind of janky pair of soft jaws there. I got a actual wrench that worked great, and on the back side of that wrench, you can see here in a minute, I use it as the cartridge holding tool. And I have a socket for the inner cartridge too, but I decided it wasn't worth doing on these forks. There you can see the wrench holding the cartridge. That's great because so all these parts are plastic, obviously, so they don't mar stuff. That's kind of the big thing that people worry about, is marring your shock components while doing this. So using steel ones or even aluminum ones they're definitely a lot better than the steel ones, but not as good as plastic. Like I was saying, I was going to do my inner chamber originally when I did this, but I did the first shock and the oil came out just like brand new, crystal clean. The bushings looked perfect. Open this one up, looks exactly the same. I'm not doing the inner chamber. The inner chamber is always cleaner than the outer chamber. There's only like 50 hours on this bike so far. The only reason I'm doing a fork service at this point is because the one fork got a nick in the tube. You'll see me polishing it up here in a minute, but that caused a little seepage in the seal, and so here I am sanding that out and then polishing it. Kind of a pain. It did get cut pretty deep, so it's going to probably leak a tiny bit every time the seal goes over it, but it's not going to be damaging the seal now that I knocked all the high spots off. So yeah, all these parts actually worked super great. I'm really happy with how all this stuff turned out. The soft jaws, I absolutely can make a better version of this. I just made it as simple as possible. I think it'd be cool to do like an angled version that also like holds it like at like a 45 in the vise to try to get it more centered in the middle without hitting the middle of the vise part on the bottom. And then also like something to hold it sideways across there, or while you're working on the inner tube, you can just kind of hold it there rather than holding it by hand. That seal driver worked fantastic. I love that thing. It was way more comfy than the last one. It's like kind of onion shaped, or maybe like a radish, or like a shallot. I think I'll call it the shallot. I like that. pretty fun. I like that. So I am hoping to get the website set up in a way that you can get the STLs for this stuff on there. Maybe sell printed versions too. That'd be great as a way to make a little bit of my investment back on this YouTube channel. But overall, this is a fun project. I think it was awesome. I saved at least $100 in tools by just doing this. So keep an eye out for the website where you can download those files or possibly buy the STLs. When I get that figured out, I'm going to be putting it in the YouTube channel bio or whatever. That's going to be a thing one day, but for now, that just kind of concludes this video. Watch out for the headlight bezel that I'll be building on this channel. And as we are welding together the laser cut parts, I'll be posting more about that too for the electric bike. And if you're interested in seeing some of the riding that I'm going to be doing in Green River, let me know and I'll do some filming down there. I think it'd be fun to do a lot of the filming of the riding that I do. But anyways, that's all I got for you on this one. We'll catch you on the next one. Thanks.